This is the second question for the matrix transformations, and we're given matrix A and B. And the first question is asking us to describe fully the geometric transformation represented by B. And again, we would think to look at our formula booklet, and matrix B has this form that it looks like it's a horizontal stretch. And I say it looks like a horizontal stretch in the fact that if we think about a stretch of -1, what does that really mean? And so I've sketched a triangle here. And if I think about the coordinates of this and applying this matrix, well, a horizontal stretch means that these points should be moving horizontally one direction or another. And if k were equal to 2, so if k equaled 2, then yes, this point would move twice the distance. So point B would be somewhere over here at 14 because we're multiplying with this scale factor of 2. If it's a scale factor of 1, what happens if it's a scale factor of 1? Well, nothing. So if I say it's a scale factor of 1, then B would just remain here at B. And so now we have to think about that it's actually a scale factor of -1. And if I were to multiply this out, and one of the things to see is, again, thinking of our matrix multiplication, we have -1 multiplying the top row, 0 multiplying the bottom. So we're going to be saying -2 plus 0, -7 plus 0. So really all I've done is I've made my top row negatives. And then if I go and multiply with the 1, 0, or sorry, the 0, 1, then my top row becomes all zeros. My bottom row, I'm just adding 0 to 3, adding 0 to 6. And so we've not done anything to the y, which makes sense as a horizontal stretch. But what we've actually done is we have reflected these points. So this 2, 3 moves over to become -2, 3, and 4, 1 reflects over to be -4, and my 7, 6 reflects over to be -7, 6. And so basically what we get is the triangles reflected along the y-axis. So this transformation is, you can think of it as a horizontal stretch, but really because of the negative sign, we have reversed everything and made the x values negative. So this is a reflection across the y-axis. And that is what matrix B really represents. So if it looks like a horizontal stretch, but you have a negative, then you know you have reflected it across the y-axis. If we think about the vertical stretch, where k is down in the lower right corner, and if that number were to be negative, then we would be reflecting it across the x-axis. So there is the first part, question 2. And now we'll look at question 2b. And 2b says there's a triangle X is mapped onto triangle Y by the transformation represented by A times B. Coordinates of the triangle are given, and they want you to find the coordinates of x. So the first thing is, what does this really mean? And so I've drawn out triangle y, because we know the coordinates of triangle y. 0, 0, negative 30, negative 20, negative 16, 32. So when they say that triangle x is mapped onto triangle y by this transformation, what that really means is there is some triangle x that by applying the transformation AB, triangle x maps onto or becomes triangle y. And so that's what this phrase, when it says x is mapped onto y, we have some x that was transformed to become triangle y. And so what we're really saying is AB times this triangle x, the coordinates of triangle x, will equal the coordinates of triangle y. And so now we're wanting to find out, well, what is x? So we need ultimately x to be by itself. So from here, what I'm thinking is I need to know the inverse of this matrix. And if I want to, I can multiply out matrix AB and then find its inverse. But right now, I'm just going to stick with the fact that what I need is the inverse of matrix AB times AB, so that those become the identity, and that is multiplied by x. And notice I've written the inverse to the left of AB, so when I write it on this side, I want it to be the inverse, and then matrix y. And matrix y, I actually sort of know. It's these coordinates, and the way we write the coordinates is x and y represents 1 point, so x and y, x and y. So in my calculator, this is what I would be typing into my calculator. I would need to type in matrix A and need to type in matrix B so that I can then group them together as the inverse, multiplying with matrix Y. And I'll tell you, I did that for you so that we find out that matrix X is equal to the points 0, 0, 10, 0, and 0, 8. And so there we've found the coordinates, but we are not done quite yet, because I just said, and the problem says, what are the coordinates of the triangle? This is the matrix representation of the triangle. So what you really need to tell me then is x is equal to the following coordinates: 0, 0, 10, 0, and 0, 8. And yes, this last step is going to be worth one of those 5 marks that you've written it as a coordinate. The 5 marks, if we go back and look at it, mark number 1 is definitely coming from recognizing that this is what you're multiplying by. So mark 1 is a method mark showing me that you're multiplying. Second mark would be then showing me that you actually have AB inverse times the matrix, and then what is your answer, and converting it into coordinates. That is how you gain those 5 marks. And there we have part B of question 2, or part C I should say. And part C wants you to find the area of triangle X. So we had just found out the coordinates of triangle X, 0, 0, 10, 0, 0, 8. And to visualize that, I do a quick coordinate graph, and what I can see is it makes a nice right triangle. So its area is base times height, 10 times 8 divided by 2 is the area, and that's 40. There's no units here, so we'll just call it units squared. We move on to part D. It says, hence find the area of triangle Y. And so I'm going to sort of get rid of a couple things here. The area of triangle Y is the map of this 40 units. So what we're saying really is that AB times X equaled triangle Y, and then we're asking about the area of these. What we need to know is the determinant. And so to answer part C, the hence is what is the determinant of matrix AB. And again, if you've already got these typed into your calculator will work that out, and it will tell you that it's negative 16. We've said prior in question number 1 that when we talk about the area scale factor, it's the determinant. A negative scale factor just means that the triangle was sort of reversed, negative image, but the area is still just going to be the absolute value of the determinant. So 16 times 40, which will be 640 units squared. So there is part D. And last, we come to part E. Part E says matrix A represents a combination of transformations. A stretch, scale factor 3, with Y as the invariant, we'll talk about that in a second, followed by a stretch, scale factor 4, X is the invariant, and followed by a transformation represented by matrix C. Now, the first thing to realize, here we have matrix A. And when we think about this, this matrix is going to equal these 3 combinations. And if I just go off to the side, if I have matrix S, T, U, multiplying some shape, so transforming some shape. The order that I do these matrices is what's closest to the shape, and so essentially for going from right, getting answer, and then multiply with matrix T, and then S. So if we think about it, what we're really saying is that U came first, followed by T, followed by S. And so if I look at what we're doing here, we're saying that matrix A is a stretch of the scale factor followed by a stretch followed by C. So I really have angle C multiplied by a, or next to a stretch scale factor 4, and then a stretch scale factor 3, X is the invariant. If you remember back to our stretches, it's saying that Y is the invariant line. What does that mean? It means on a coordinate graph that the Y-axis, being the invariant, is, how do I say, invariant means the point on that line would not move. So if I have a point here on the invariant line, it doesn't move. And so this stretch and we're thinking of stretch and scale factors, so we're looking at these two corners, and when it says it's a scale factor of 3, well, that tells me I have 3, 1, and 0, 0. So what it's really saying is this is a stretch parallel to the x-axis, where y, this invariant line, is sort of the base from which we're stretching. And so when our next one is that it's followed by a stretch of scale factor 4, x is the invariant line. So if x is the invariant line, what that means is that my stretch, my x is the invariant line, and so everything stretches away from the invariant line, so it's parallel to the y-axis, which is telling me, yeah, this is a stretch parallel to the y-axis, which is this matrix, and then we have multiplied by c. So what do we know? We know that this matrix A equals C. Multiply these two together and we come up with 3, 0, 0, 4. And to find C then, we want to multiply with the inverse of this matrix, which, just for sake of sort of what we're talking about, let's call this matrix K. And so I need to multiply matrix K by its inverse so that we can get C by itself. And I write this out to show that K, this inverse matrix, is going to be written to the right of the matrix. And so over here, when I'm thinking about this, I have 3, 2, negative 2, 4, and to the right of it is where I need to place matrix K. So again, I would go to my calculator to find out what is the inverse of 3004 and multiply it. I basically just type in my calculator 3004 as a matrix, multiply it with the inverse, and I can tell you that ultimately we find out that C is equal to this matrix, which is negative half, 2/3, and 1. So that's what you should get as a final answer. Decimal value, you can have the calculator tell you what it is as a fraction or leave it as the decimal.